Ever wondered what's really happening under the hood of your car? That intricate dance of metal parts that turns fuel into motion? Today, we're diving deep into the heart of most vehicles on the road, the four-stroke engine. Whether it's in a car, a motorcycle, or even a lawnmower, this incredible invention is a masterpiece of engineering. It's called a four-stroke engine because it completes its power-generating cycle in 4 distinct steps, or strokes, of the piston. By the end of this video, you'll understand exactly how these 4 simple movements create the power that gets you from point A to point B. So, buckle up as we take a journey inside the engine. First, let's get familiar with the main characters in our story. At the center of it all, we have the cylinder, which is basically a hollow tube. Inside the cylinder, we have the piston, a solid plug that moves up and down. This piston is connected to a crankshaft via a connecting rod. Think of the crankshaft like the pedals on a bicycle. When you push the pedals up and down, they turn a crank, which makes the wheels spin. The piston's up and down motion does the same thing to the crankshaft, creating rotational power. Finally, at the top of the cylinder, we have 2 critical gateways, the intake valve and the exhaust valve. These valves open and close at precise moments to let things in and out of the cylinder. Together, these parts, the cylinder, piston, crankshaft, and valves, work in perfect harmony to make the magic happen. Alright, let's start the cycle with the very first stroke, the intake stroke. Imagine the piston is at the very top of the cylinder, ready to begin its journey downwards. At this exact moment, the intake valve opens up. As the piston moves down, it creates a vacuum inside the cylinder, just like when you pull back the plunger on a syringe. This suction pulls a mixture of air and fuel from the car's fuel system into the cylinder through that open intake valve. The exhaust valve, by the way, stays tightly shut during this entire process. The goal here is simple. Fill the cylinder with as much of this combustible air-fuel mixture as possible. The more mixture we can get in, the more powerful the eventual explosion will be. By the time the piston reaches the bottom of its travel, the cylinder is completely filled, and the intake stroke is complete. Now, the stage is set for the next step. With the cylinder full of the air-fuel mixture, the piston begins its journey back upwards. This is the second stroke, called the compression stroke. Just as the piston starts to move up, the intake valve snaps shut. Now, both the intake and exhaust valves are completely closed, sealing the cylinder. As the piston travels upwards, it squeezes that air-fuel mixture into a much smaller space at the top of the cylinder. Why do we do this? Compressing the mixture makes it far more volatile and energy-dense. It's like coiling a spring. The more you compress it, the more powerful its release. This high-pressure environment is crucial for getting the most energy possible out of the fuel. By the time the piston reaches the top of its stroke, the mixture is highly compressed and ready to be ignited. This compression is key to the efficiency and power of the engine. Now for the main event, the stroke that gives the engine its name, the power stroke. With the piston at the very peak of its travel and the air-fuel mixture under immense pressure, a tiny but mighty component comes into play, the spark plug. The spark plug emits a high-voltage electrical spark, instantly igniting the compressed mixture. This creates a controlled explosion inside the cylinder. The rapid expansion of hot gases from this explosion generates an enormous amount of pressure, forcing the piston down with incredible force. This is the only stroke in the entire cycle that actually produces power. This powerful downward push on the piston is what forcefully turns the crankshaft, creating the rotational energy that eventually makes its way to the wheels of the car. It's this violent, energetic push that truly drives the vehicle forward. Both valves remain firmly closed throughout this stroke to ensure all the explosive force is directed onto the piston. After the power stroke, the cylinder is filled with burnt gases, or exhaust. We need to get rid of these waste products to make room for the next cycle. This brings us to our 4th and final step, the exhaust stroke. As the piston reaches the bottom after the power stroke, the exhaust valve opens. The momentum from the crankshaft then pushes the piston back up the cylinder one last time. As the piston moves up, it acts like a plunger, pushing all the leftover burnt gases out through the open exhaust valve. These gases travel through the exhaust system and out the tailpipe of your car. The intake valve remains closed during this process, to ensure the exhaust gases do not contaminate the incoming fresh charge on the next cycle. Once the piston reaches the top, pushing out all the exhaust valve closes. And just like that, we're right back where we started, ready for the next intake stroke to begin the entire 4-stroke cycle all over again. So, to recap: intake, compression, power, exhaust. Intake draws the mixture in, compression squeezes it, power ignites it to create force, and exhaust pushes the waste out. This 4-stroke cycle happens hundreds, even thousands of times every minute. But how do the valves know exactly when to open and close? That's the job of another crucial component called the camshaft. The camshaft is a rotating shaft with lobes, or bumps, on it. As it spins, these lobes push open the intake and exhaust valves at precisely the right moments in the cycle. The camshaft is connected to the crankshaft, usually by a timing belt or chain, to ensure they are perfectly synchronized. This precise timing is what keeps the entire engine running smoothly and efficiently. If the timing is off by even a fraction, the engine can run poorly or not at all. It's this perfect high-speed choreography of moving parts that makes the 4-stroke engine so effective. Now that we understand the theory, let's look at where these engines are used in the real world. The most obvious application is in our cars, trucks, and SUVs. The engine under your hood is likely a 4, 6, or 8-cylinder 4-stroke engine. Each cylinder is performing this cycle, timed to fire in a sequence that provides smooth, continuous power. But it doesn't stop there. Motorcycles, from small scooters to large cruisers, rely on the power and efficiency of the 4-stroke design. You'll also find them in many boats, where they're known as inboard or outboard motors, and they're not just for transportation. Portable generators that provide electricity during a power outage are often powered by a small 4-stroke engine. The same goes for lawnmowers, pressure washers, and many other pieces of outdoor power equipment. Its reliability, efficiency, and versatility have made the 4-stroke engine one of the most important inventions of the modern era, quietly powering our world in countless ways. Thank you so much for joining me on this deep dive into the 4-stroke engine. Hopefully, you now have a much clearer picture of the incredible process that happens every time you turn the key. If you enjoyed this video and learned something new, please give it a thumbs up and consider subscribing for more engineering explanations. Let me know in the comments what topic you'd like to see me cover next. Thanks for watching.